This section of your flipbook is all about the intercept form of a quadratic, the intercept form. And let's go ahead and start off the video by writing out what the intercept form looks like. It will look like y equals a times x minus p times x minus q. And some things to think about here is, one, you can see there are no squared terms showing in intercept form, even though there isn't a squared x, but it's been factored, so you don't see a number 2 or an exponent of 2 anywhere here. And also this p and q, you'll see later, those will relate to the actual x-intercepts of this form. The a value works exactly the same way as vertex and standard form. If a is negative, the parabola opens down. If a is big, the parabola stretches. If a is less than 1 or greater than 0, or the absolute value of a is less than 1 or greater than 0, we will have a compressed parabola. Now, while we're working through this video, we're going to go ahead and do some examples to show you how the different parts of the intercept form look. So we're going to write an equation here that we're going to work with. So let's use a practice equation of y equals, let's put an a value of 3, and then we'll put x plus 1 and x minus 4. So there are our two binomials. And again, notice there is no exponent of 2 written because this is fully factored. Okay, so how do we find the x-intercepts of an intercept form quadratic? And just a reminder to you, x-intercepts can be called zeros or solutions, and also they can be called roots. So x-intercepts are easy. That's why we call it the intercept form, because the x-intercepts are right here in the equation. So p and q are going to be our x-intercepts, but let's go ahead and write this out. Take each term with an x value, or with an x variable, set it equal to 0, set it equal to 0, and solve for x. So let's take a look at how that works with our example. We've got y equals 3 times x plus 1 times x minus 4. All we're going to do is take the two terms that have an x variable, so we can treat this binomial as a single term because we're multiplying 3 times the binomial. And we're going to take that binomial and we're going to set it equal to 0. Let's solve that. We're going to subtract 1 from both sides, and we end up with x equals -1. There is our first x-intercept. We're going to cross the x-axis at x equals -1. And now let's go ahead and set our second binomial equal to 0, or our second term. Actually, it's our third term here. 3 is a term. So we're going to take that term that has an x in it, and we're going to set it equal to 0. Use a little algebra here. Add 4 to both sides, and you've got x equals +4. So that's all there is to it. We can write our answer down here. So the x-intercepts are at -1 and 4. Now, just another common thing to show you, class, it's common that we actually can write this as, and I'll put this in the margin. Actually, you know what? We'll just put it right above this. We can write this as x is equal to, and then in pointy brackets, either -1 or 4. This means x can include the set of numbers -1 and +4. Alright, so x-intercepts are easy to find with intercept form. Talked about this already a moment ago. How does a affect the graph? Well, it looks exactly the same as vertex or standard form. let's put our first little thing here, our first dot, positive a. The graph points up, or faces up, or opens up. Negative a. Graph is going to turn upside down, or reflect, it's going to open down. And then one more thing. As the absolute value of a increases, the graph stretches. And this is the same again for all three quadratic forms. See if I can get the word stretches to show up in here. I'm going to make this a little bit narrower. The graph stretches. Alright, so that means when a gets really, really small, less than 1, and approaches 0, we get a compressed graph. Alright, let's take a look at last question. How do the x-intercepts affect the graph? What happens when our x-intercepts move? Well, it's kind of difficult to explain, but we can explain it this way. Changing the x-intercepts will change where the graph crosses the x-axis. And that makes sense, since the x-intercepts are where we cross the x-axis. When these numbers, as -1 and 4, as they shift around, then the x-intercepts change, and that means the parabola is going to cross the x-axis at different points. So x-intercepts can make it wider, narrower, it can move it around location-wise. So changing the x-intercepts will change where the graph crosses the x-axis.